So you got the notes for section 5.4, which is with the multiple angle identities. So the first one we've got is the double angle. So here's sine's double angle. It should be 2u, not sine squared. So the 2 should actually be a coefficient on the u mostly. So it looks like this, so on and so forth. So prove the identity. Sine 2u equals 2 sine u cos u. Well, sine 2u is the same thing as sine u plus u. So this is a sum. So the rule for sine sum is sine of the first, cosine of the second, cosine of the first, sine of the second. Now, since order of multiplication doesn't matter, I can rewrite the second one as sine u cosine u, 2 identical copies, and there you go, which is exactly what I have on the right. All right, power reducing formulas let you reduce squared functions down to things that include essentially a double angle. So then you can also substitute the double angle in to get something even more cleaned up. So here we've got example 2, prove that identity cosine of the fourth minus sine of the fourth is cosine 2 theta. So this is actually difference of squares. So I can factor it cosine squared minus sine squared, cosine squared plus sine squared. So this guy over here, that's all just 1. And if you look at your formulas, cosine squared minus sine squared, cosine squared, whoops, not on the screen. Cosine squared minus sine squared is the same thing as the cosine of 2 times the angle. So all of this is just cosine 2 theta, which is what I have on the right. All right, we write cosine to the fourth in terms of a trig function, no power, greater than 1, which means I need to do a bunch of power reducing formulas to get everything down to the first. So the first thing I can do, cosine to the fourth, that's the same thing as cosine squared. So I can use one of the power reducing formulas. So cosine squared of x, go with here. That's this, so I'm going to replace with that stuff. So this becomes, let me come back down here, 1 plus the cosine of 2x all over 2 quantity squared. Now, since I'm squaring, I can work this out. So there's a FOIL on the top, square on the bottom. So this stuff squared is 1 plus 2 cosine 2x plus cosine squared 2x all over 4. So this is the same thing as 1/4 plus 1/2 cosine 2x plus 1/4, and I can reduce this guy again using the same formula. So 1 plus cosine, it's actually going to be 4x here. The reason that it becomes a 4x is that the formula has a 2x in it already, and my angle is still 2x, so double. So whatever the angle is here gets doubled. So x becomes 2x, which means 2x has to double to become 4x. So I have 1/4 plus 1/2 cosine 2x plus 1/8 plus 1/8 cosine 4x. So it looked like this. These guys are like terms, so I essentially distributed the 1/4. So there's 1/2 times 1/4 is 1/8. 1/4 times cosine over. So that's 2/8, so that's going to be 3/8 total. Cosine 2x plus 1/8 cosine 4x. So there you go. Everything in terms of no higher powers. Our half angles, so tangent has multiple different versions you can use. Here's the sign. Notice that there are positives and negatives because when you take a square root, you get 2 solutions. So here's your half angle identities. Okay. Solving trig equations. So solve on the interval 0 to 2 pi, sine 2x equals cos x. So the first thing we're going to use is our double angle formula to simplify that left-hand side. So we're using this one. So on the left-hand side, this becomes 2 sine x cosine x equals cosine x. So I'm going to move everything left. So look like this. I can factor a cosine out. So 2 sine x minus 1 equals 0. So now I'm factored. I set the factors separately equal to 0 and solve. So cosine x is 0, so I need all the angles to have cosines of zeros. That occurs at pi over 2 and at 3 pi over 2. Here, I'm looking where the sine x is equal to 1/2, which occurs at, let's see here, pi over 6 and 5 pi over 6. So there are 4 angles that solve that equation in order. Least, and then it'd be this one, and then it would be 5 pi over 6, and then 3 pi over 2. So those are my 4 angles that solve that equation. Now if it said find all, I would just put plus 2 pi n's after each of these, or minus 2 pi n's. Okay, so solve the equation sine squared x equals sine squared x over 2. So we've got, looks like a half angle in there, so we're going to use our half angle formula. Oops, where is it? Get it all on there. So we're using this guy. Now notice, because this is sine squared, it's going to take that square root off. So sine squared x equals 2, and then 1 minus cosine u over 2. Because the squared here, that squared cancels that root out. Now, since I have cosines on the right, I'm actually going to turn this left-hand side right in terms of cosines. So I'm going to use a Pythagorean identity, which gives me this, and this just becomes 1 minus cosine, oops, x. So bring everybody to one side. The ones are going to cancel. So I'm going to have the cosine of x minus the cosine squared of x is equal to 0. Can factor out a cosine, 1 minus cosine x. So now that I'm factored, I set my factors separately equal to 0. So the cosine is 0. 1 minus the cosine is equal to 0. So this becomes cosine of x is equal to 1. Subtract the 1 across, divide by -1. So the places that the cosine is 0, pi over 2, 3 pi over 2. Places the cosine is 1, that's actually at 0 radian. But since it says solve, it doesn't say in an interval, I need to do all of them. So 0 plus 2 pi n, pi over 2 plus 2 pi n, 3 pi over 2 plus 2 pi n. Sometimes this one would just be written as 2 pi n, because 0 plus anything, where n is equal to plus or minus 1, plus or minus 2, plus or minus 3, so on and so forth. So those are all of your solutions, which is the end of this section.